Welcome to the Deep Dive. This is where we take the sources you send us and, well, we dig in.
We do indeed.
And today, you've pointed us towards Asfaltovenator. It's a dinosaur name that's been popping up. Seems like a real game changer in some ways.
It certainly is causing a stir, yeah.
So our mission, for you listening, is to get under the hood of this discovery. Why is Asfaltovenator significant? What's it telling us about dinosaur evolution, its world? You want the key info, quick but thorough. So let's get started.
Absolutely. So Asfaltovenator, it's a theropod found in Argentina. The story really kicks off back in 2002. A technician, Leandro Canessa, stumbled upon the first bones near a place called Cerro Condor.
Okay, 2002, but discovery is just the start, right?
Oh, definitely.
Yeah.
The main excavation didn't happen until a bit later, between 2005 and 2007. And then the really time-consuming part began. Mariana Caffa led the preparation, and it took 5 whole years.
5 years. Why so long?
Well, the fossil was embedded in this extremely hard rock, this matrix, so just getting it out cleanly was a massive job. It wasn't really until, say, 2013 to 2015 that they could properly start comparing it to other related theropods.
Wow, that's some serious dedication. A real labor of scientific love, you could say.
You really could.
And when did it finally get its official name, its scientific debut?
That happened in 2019. Oliver Walter, Misha Rohut, and Diego Pol, they were the ones who formally described it and gave it the name.
Asfaltovenator, what does that actually mean?
It's quite descriptive, actually. Asfaltovenator literally means Cañadón Asfalto Formation Hunter.
Ah, named right after the rock layer it came from. Makes sense.
Exactly. And the species name Vialidad. That's a nice touch. It honors the Dirección Nacional de Vialidad, Argentina's national road agency. They apparently gave some crucial help during the recovery.
That's great, acknowledging the support. And there's a specific reference fossil, right? The holotype.
Yes, MPEF, PV3440. That's the benchmark specimen, the one everything else gets compared back to.
Gotcha. Okay, so that covers the discovery, the naming, the backstory. Now let's talk about the dinosaur itself. What did it actually look like? What era are we in?
We're in the lower Jurassic period, specifically the rock layer it was found in that's dated to the Middle Tortian epoch. So think around 179 to 178 million years ago. And the dating suggests it's probably closer to the 178 million mark.
Middle Tortian. Okay.
Yeah.
And how much of the dinosaur do we actually have? Is it just a few fragments?
No, actually, it's surprisingly complete in parts. It's a partial skeleton, sure, but a very informative one. We have a mostly complete skull, which is fantastic.
Oh, wow.
Yeah, and the lower jaws, too. Plus, a good chunk of the skeleton from the neck back to just before the hips. Also, some bits of the pubic bones and parts of the right hind leg.
Like what parts of the leg?
The lower end of the femur, the thigh bone, and the upper parts of the tibia and fibula, those are the main low leg bones, and even some foot bones, so quite a lot to work with.
That really does sound like a paleontologist's dream. Gives you a good picture. And size-wise, you mentioned comparisons to Allosaurus earlier.
That's right. It was a large predator, definitely in the same league, size-wise, as the later Allosaurus.
So how big are we talking?
The skull alone is estimated between 75 and 80 centimeters. That's, what, about 2.5 feet long?
Just the skull.
Just the skull. Based on that and the other bones, the estimate for total body length is somewhere around 7 to 8 meters.
So 23 to 26 feet. That's it's a big animal.
Bad.
Absolutely formidable.
No question. A top predator of its time.
Okay. Now, you mentioned the researchers highlighted some unique things about it. Distinguishing features. What made Asfaltovenator stand out?
Right. They identified several, including what scientists call autapomorphies. Think of them as unique evolutionary trademarks, features found only in this specific dinosaur.
Like what, for instance?
Well, take the teeth at the very front of the upper jaw, the premaxillary teeth. They have serrations, like tiny steak knives, and also a small hole, a foramen. Now, what's interesting is, while these are distinct for Asfaltovenator in its context, similar features are seen in some more primitive, earlier theropods.
Well, like which ones?
Things like Dilophosaurus, the one with the crests.
Yeah.
And Dracovenator. Even Proceratosaurus, which is actually closer to the line leading towards tyrannosaurs and birds. So it's got this sort of mix of older and newer traits right there in the teeth.
Huh. So echoes of its ancestors, maybe?
Possibly, yeah. Or maybe features that popped up independently. Then there are other things, like these bony plates on the inside of the tooth-row periodontal plates and a shelf on the roof of its mouth.
And who else had those?
Those are shared with ceratosaurians, another major theropod group, and some others too. But then adding to the complexity, it also shows features that look very much like allosauroids.
Okay, wait. Allosauroids.
Yeah,
Like Allosaurus.
exactly. especially in that front upper jawbone, the premaxilla, but also the main upper jawbone, the maxilla, and the bone in front of the eye, the lacrimal. It even has a little bony ridge above the eye socket, a supraorbital crest, which is very allosauride-like.
So it's borrowing features from all over the place.
It really seems like it. And just to complicate things further, some of those allosaurid features, you actually see them in some megalosauroids too.
Right, another group of big predators.
Yeah.
Wow, it sounds like a real evolutionary melting pot.
That's a very good way to describe it, yeah.
Were there any other really specific, maybe kind of quirky anatomical details they noted?
Oh, sure. At the back of the skull, on the x-occipital bone, there are these very distinctive horizontal ridges. They sit between side projection, the paracipitал process, and the big hole where the spinal cord connects the foramen magnum. That's quite unique.
Okay.
And also, the third and fourth neck vertebrae, their spines are triangular and sweep backwards. And further down the back, on the 11th and 12th vertebrae, there's an extra little ridge on the bit where the rib attaches.
It's amazing how these tiny details are the clues, isn't it?
They're crucial. They're the characters we use to try and build the family tree.
So speaking of the family tree, how does this jigsaw puzzle of features help us figure out where Asfaltovenator fits? Its classification.
Well, this is where it gets really interesting and honestly a bit messy for the old classifications, because Asfaltovenator has this blend of primitive and more derived, more advanced features within the big group called Tetanura.
Tenere, stiff-tails, right? That's most of the big meat eaters, plus bird ancestors.
Exactly. Megalosauroids, allosauroids, coelurosaurs, they're all tetanurans. And because Asfaltovenator has this confusing mix, putting it into phylogenetic analyses, those computer programs that build family trees based on shared traits, well, it really shook things up.
Shook things up how? Like it didn't fit neatly?
Precisely. The initial studies actually placed it as a basal allosauroid, sort of an early offshoot of the allosaurid line, positioned somewhere between earlier groups like Piatnitskysaurids and later ones like Metriacanthosaurids.
Okay, so an early allosaurid relative.
Right. But that finding itself was significant. It challenged the idea that there was this neat ladder-like progression from megalosauroids up to allosaurids. Asfaltovenator suggested it was more tangled.
More like a bush than a ladder.
Kind of, yeah. It hinted that maybe the traditional group Megalosauridea wasn't a single unified branch, but more like a grade, a series of steps leading towards Allosauridea.
So it blurred the lines between those big groups.
It did. And its unique feature set even raised the possibility that maybe megalosauroids and allosaurids were more closely related to each other than either was to the coelurosaurs. That would be a big shift in thinking.
Wow. Okay. But you said initial studies. Has the thinking evolved since 2019?
Oh yes, science moves on. In 2024, for instance, Andrea Cao proposed a different spot for it, maybe closer to a little feathered dinosaur called Cyrumimus, placing it potentially within a broader Megalosauridae concept.
That's quite different.
It is. But then also in 2024, Oliver Rohut, one of the original describers and colleagues, published work arguing, based on their analysis, that Asfaltovenator fits firmly within the Allosauridae family. So closer to Allosaurus itself.
Okay, so back towards the allosaur side of things.
Right. And there's ongoing detailed work on its bones, its osteology, which seems to lean towards that allosaurid connection in some analyses too, maybe even a sister taxon to Allosaurus or just outside that immediate family, but still clearly an allosaurid.
So it's still a bit of a moving target depending on how you run the analysis.
Exactly. A study in 2025 describing another dinosaur, Tamaryraptor, also found Asfaltovenator nested within Allosauridae in some of their trees, but stressed that this result depended heavily on the specific methods used.
So the jury's still out on the exact pinpoint location.
A little bit, yes. What is becoming clearer, though, is that the old idea of Carnosauria, that group that traditionally lumped megalosaurs and allosaurs together, isn't consistently holding up in these newer analyses. And interestingly, other tetanurans found nearby in the same formation don't seem to be close relatives. Asfaltovenator seems somewhat unique in its local fauna.
Fascinating. So it's this really pivotal, maybe slightly problematic fossil for understanding how these huge predators are all related. Let's shift focus a bit, though. What about the world it lived in? Its paleoecology.
Right, the environment. It comes from the Chacretus member of the Cañadón Asfalto Formation, and the rocks tell a story of lakes and rivers, fluvial and lacustrine deposits.
So water was around.
Definitely. But also fire, in a sense. There are layers of tufaceous material that's volcanic ash, so there was volcanic activity nearby shaping the landscape.
A dynamic environment, then. Lakes, rivers, volcanoes.
Pretty much. At specific fossil sites like Cerro Condor, we see signs of palestrine littoral environments. Think sort of marshy lake edges. You get these lake limestones layered with shales and those volcanic tuffs.
And the lake itself, what was it like?
Well, the evidence suggests the Chiquita's member lake system was likely saline, maybe even hypersaline, very salty, and hydrologically closed, meaning it didn't drain out into a major river or the sea. Probably quite shallow, like a pan lake, with gently sloping, ramp-like margins and these marshy bits around the edges.
Huh. Salty, shallow lake. Any modern places that are similar to help us picture it?
Yeah, scientists have drawn comparisons. Lake Magadi in Kenya is a modern hypersaline alkaline lake that might be a good analog for the water body itself.
Okay.
And for the surrounding volcanic environment, maybe something like the Waimangu Volcanic Rift Valley in New Zealand gives a sense of it. The bigger picture, the large-scale volcanism, might relate to the formation of the Chon Ike province, a huge volcanic region, perhaps similar in development to volcanic fields in California today.
So, hot, salty, volcanic. Quite an extreme place to live, potentially.
It certainly sounds like it wasn't your average lush, green Jurassic landscape in that particular spot.
Now, the sources also brought up something called the Torsion Oceanic Anoxic Event, the TOAE. How does that fit into the story of Asfaltovenator?
Ah, the TOAE. Yes, that's becoming a really key piece of the puzzle for understanding Jurassic evolution. It was a major global event linked to massive volcanic eruptions, the Karoo-Ferrar Large Igneous Province. These eruptions pumped huge amounts of greenhouse gases into the atmosphere, leading to ocean warming, deoxygenation, the anoxic part, and several pulses of extinction.
Okay, a major environmental crisis.
A huge one. We know it had a big impact on marine life that's well documented. But its effect on land animals, especially early theropods like the ancestors of Asfaltovenator, has been, well, less clear.
But Asfaltovenator lived right around that time, didn't it? You said Middle Torsion.
Exactly. Its presence, along with other early Avrostrands, the group containing allosaurids and coelurosaurs in rocks dating to just after the main Toei phase, is really suggestive.
Suggestive of what?
That perhaps the Toei, despite being an extinction event, might have actually triggered a burst of diversification in these surviving dinosaur groups. We see a pattern around this time. Rapid morphological evolution, lots of changes in shape and form, followed by a sort of stabilization in the Middle Jurassic. That pattern echoes what we see after other mass extinctions.
So the crisis cleared the way, opened up ecological opportunities.
That's the main hypothesis, yes. It's called ecological release. After dominant groups are hit hard by extinction, the survivors can rapidly evolve and diversify to fill those empty niches.
Makes sense.
Of course, it's complex. Reconstructing the exact lines of descent is tricky because the fossil record is incomplete, and you get things like homoplasy, where similar traits evolve independently, confusing the picture. But the timing is certainly compelling. Asfaltovenator appearing when it did, where it did, seems very much tied into the aftermath of this global event.
Right, so let's try and sum this up. Asfaltovenator. It's this remarkable predator from the early Middle Jurassic of Argentina. Lived around 178 million years ago, right after this major global crisis, the TOAE. It was big, maybe 7-8 meters long. And crucially, it has this really weird mix of features. Some primitive, some like allosauroids, some like ceratosaurs or megalosauroids.
The unique mosaic, definitely.
Which makes it super important, but also kind of difficult for figuring out how all these big predatory dinosaur groups, the Titaniurans, are related. Its exact spot on the family tree is still being debated.
That's a fair summary, yes. Still an active area of research.
And it lived in this pretty harsh environment, salty lakes, volcanic activity nearby. Not exactly Jurassic Park.
Probably not, no. A very different kind of lost world.
So this one dinosaur discovery, as Asfaltovenator, really gives us this incredible window into a complex time, a time of environmental upheaval, extinction, and rapid evolutionary innovation among the survivors.
It really does. It highlights how interconnected everything is: geology, climate, extinction, evolution.
Absolutely. It really drives home how these massive environmental shifts, even hundreds of millions of years ago, were powerful forces shaping the diversity of life. And it makes you think, doesn't it? What other discoveries are out there buried, waiting to completely change our understanding again?
Always more to find.
And for you, listening,
Yeah.
maybe think about your own areas of interest. What happens when you take one specific piece of information, one source, and really dive deep? What connections might you uncover? What larger picture might emerge? Thanks for joining us on this deep dive.